Basic integration 4. A ball is thrown downwards with a speed of 10 meters per second from the edge of a cliff 100 meters above the ground. Find the equation for the height of the ball t seconds later. We can ignore wind resistance. Solution. We choose the upwards direction to be positive and the downwards direction to be negative. And since the force of gravity is downwards, the acceleration of the ball must be negative. And the initial velocity of the ball is also negative since the ball is thrown downwards. Acceleration is minus 9.8, the initial velocity minus 10 meters a second, and the initial height 100 meters. Recall that the velocity is a derivative of position and acceleration is a second derivative of position. Let's begin. So we integrate the second derivative to get s prime. S prime of t is integral negative 9.8 dt. And that gives us s prime of t is negative 9.8 t plus a constant of integration plus c. Now we have initial condition v of 0 is negative 10. So I can put minus 10 equal to minus 9.8 times 0 plus c. Solving for c, we get c equals negative 10. Plug this back into s prime of t. This is the velocity function. This is negative 9.8 t minus 10. Now we integrate this again to find s of t, the height function. S of t will be the integral s prime of t dt. That's integral negative 9.8 t minus 10, all integrated with respect to t. So s of t will be equal to integral negative 9.8 t dt, splitting up the integrals, minus integral 10 dt. The constant passes right through the integral, and the 10 also passes right through. So we get negative 9.8 integral t dt minus 10 integral dt. Okay, so we have s of t is equal to minus 9.8 integral t dt minus 10 integral dt. That's going to be minus 9.8. Integrate t, reverse the power rule, that's t squared over 2. Minus 10 integral dt. You can put a 1 here and say what is the function whose derivative is 1? That's t. So minus 10t. Derivative of t is 1. Plus another constant, I'll call it d. That's s of t. Now we want to solve for the initial, we have the initial height, which is s of 0 is equal to 100. Let's use the initial height to solve for the height of the ball at time t. So 100, that's the position, is negative 9.8 times 0 squared over 2 minus 10 times 0 plus d. Note, this expression means when t equals 0, s of t is 100. Okay, so this is all 0, this is 0. We solve for d, d is equal to 100. If you put this back in, we get s of t is negative, and 9.8 divided by 2, that's 4.9 t squared minus 10t plus 100. This is the height of the ball, height of ball, t seconds after it was thrown from edge of cliff. This is the height function. Okay, thanks.